So, good evening, all, and welcome to the live stream. So, today in this live stream, I shall be sharing some basic concepts, some short tips and tricks, and I also will be solving some examples. And these tips and tricks will definitely help you in your upcoming board exams. And some of these tips and tricks will also help you in some aspects of the competitive exams, such as JEE and NEET. So, without any delay, let's begin. So today I shall be sharing some very basic concepts of chapter electrochemistry. Now, whenever a student wants to study electrochemistry, so what should be the ideal start to electrochemistry? What I mean to say is, should you directly focus on some of the theories, or should you first read some theory part and then go with the numericals? Because electrochemistry is a lengthy chapter in the physical chemistry portion, and it also has various numerical parts in it, which are directly asked in board exams. So let's begin. Okay. So starting off with the definition of electrochemistry. See, what is this electrochemistry? So basically, electrochemistry is a type of chemistry, or it is a science that deals with the study of chemical energy and electrical energy and their interconversions. Okay, so electrochemistry deals with the study of conversion of chemical energy into electrical energy or electrical energy into chemical energy. Now, after discussing the basic definition of electrochemistry, we have electrochemical cell. Electrochemical cell. So, electrochemical cell. So, we have basically two types of electrochemical cell, which are galvanic cell or voltaic cell. And another type of electrochemical cell which we have is electrolytic cell. Okay, so we have two types of electrochemical cell. Now, before I get into more detail about what is exactly is galvanic and what exactly is electrolytic cell, one very basic important point of this chapter is, see, whenever we are talking about anode in electrochemical cells, or whenever we will talk about Nernst equation, or when we'll move forward in the chapter, you always have to remember that at anode your oxidation always takes place. Correct? What is oxidation? So oxidation refers to loss of electrons. Loss of electrons. And at cathode, reduction always takes place. So what do I mean by reduction? By reduction, I mean gain of electrons. Now, talking about electrochemical cell, so what exactly is the purpose of galvanic cell? So our galvanic cell converts chemical energy into electrical energy. So I will write over here, converts chemical energy to electrical energy. Okay, now whenever we talk about electrolytic cell works the opposite way. It converts electrical energy into chemical energy. Correct. Now, the normal cells, or double A or triple A batteries that you use in your homes are these galvanic cells. Those are galvanic cells, because as you see, you have some chemical energy stored in the cells, which is being converted into electrical energy. Correct. Now, moving on. First, we are going to discuss galvanic cell. or voltaic cell. Okay. So, as I already told you, galvanic cell or voltaic cell is that type of electrochemical cell which converts chemical energy into electrical energy. Correct? Now, if we come, okay, so in this we have Daniel cell. This is a basic type of galvanic cell which is usually discussed in your NCRT books, and this is very, very important with respect to your board exams or any competitive exams because working of Daniel cell is very, very basic and it is asked everywhere. So, first we discuss Daniel cell. Now, we have some. Okay. So, in Daniel cell, you have a cathode, you have a anode. Now, this part is your anode, and this part is your cathode. In Daniel cell, you have your anode as zinc, and your cathode is copper. Now, did we take zinc and why did we take copper as a cathode and why zinc as anode? I will tell you later on. So now, this is filled with some electrolytic solution, and here also this is completely submerged in some electrolytic solution. Now, this is a salt bridge. I shall tell you the function of salt bridge also when we study this. Now, see what happens in your Daniel cell, your zinc, this part is anode. So as I told you, what happens at anode, your oxidation takes place. So so your zinc, this gets converted into zinc plus 2 electrons. Correct? And this is your oxidation half reaction. Now, so your electrons will move from here. Okay. And see, electrons are moving in this direction. So the direction of electric current is definitely opposite to the direction of flow of electrons. So the direction of electric current will be in the opposite direction. Now, this is your galvanometer, basically to detect the flow of current, whether there is a flow of current or not. Now, what happens? Your zinc gets converted into Zn plus 2 ion and electrons flow from here. Now, you have a similar reaction. So what will happen here? Zinc plus 2 ions will start depositing over here. And here what will happen? Here you will have reaction something like this. Your copper plus 2 ions in aqueous form, they get electrons and they get deposited as copper. This will be your reduction half reaction. So this is your oxidation half reaction and this is your reduction half reaction. So here you must be having some copper plus 2 ions which definitely now stick as copper and they get solidify as copper at cathode. This was anode. This is your anode and this is your cathode. C. Okay, so this was some basic working. Now what is the function of this salt bridge? Why are we having this salt bridge at first? So see what happens. Your zinc is getting converted into Zn plus 2. Copper from copper plus 2 aqueous state is getting converted into copper solid. So what will happen after some time this Daniel cell keeps on working, a neutrality in ions will come and this flow of electrons will cease. There will be no flow of electrons. So so as to you can say uh, cancel the neutrality, we use salt bridge. Okay, this salt bridge has this function. So what are the components of this salt bridge? So your salt bridge, it is made up of concentrated strong electrolyte. Okay, so your salt bridge, so it is made up of concentrated strong electrolyte plus agar agar gel, agar agar gel plus some semi-solid paste. So now what happens? See, your Zn plus 2 ions are here in this anodic compartment, and your copper plus 2 gets deposited as copper. So see what will happen after some time, the flow of electrons will cease. So your salt bridge functions to maintain the neutrality between both the components of the Daniell cell. Okay. Now, this salt bridge completes the inner circuit. So I will write over here, salt bridge completes the inner circuit. One very star mark point, which is mostly asked in board exams directly as a 1 mark question, is that your salt bridge, it has the electrolytes of the salt bridge or the contents of the salt bridge have no involvement with the directly with the reactions of the Daniell cell. The salt bridge is simply just added so that the electrical neutrality is maintained and the flow of electrons continue. If there were no salt bridge, at some point of time, the flow of electrons will cease because at one place you will only have Zn plus 2 ions and at one place you will only have copper deposited. Your Cu plus 2 ions get deposited as copper on the cathode. So there will be no flow of electrons further. So that is why we have added salt bridge so that the electrical neutrality is constantly maintained and your flow of electrons continues as such. Okay. Now, moving on. So we have now our cell representation. We talked about types of electrochemical cells, and then we have talked about your galvanic cell and a type of galvanic cell, Daniell cell. We discussed its working. Now we come to cell representation. This is a very important topic, you can say, because if you don't know how a cell is represented, you cannot solve any type of questions in your board exams. Because in board exams the questions will be directly asked, you will be given a format, a type of cell, and there will be some reactions you have to solve. So if you don't remember this cell representation, it is going to be very troublesome for you. So I have a simplified method. So how do we represent? So LOAN, I have generalized this cell representation into this format. So your L here represents left, O represents oxidation, A represents anode, and N represents negative. Okay, so whenever you will be representing a cell, you have some set of rules which you have to follow. So suppose now I'm trying to represent my Daniell cell as such. So how is this Daniell cell represented? So it will be represented as like this. So you have zinc, solid, one straight line, and then you have zinc plus 2 ions in aqueous state, and its concentration, we suppose it in denatile, has to be 1 molar. Further, you have your copper plus 2 aqueous, again 1 molar, and this is getting converted to copper solid. So this is your cell representation for Daniell cell, and you can try to remember it using this LOAN, lone. Okay, so left. So on this left side, you have your anode part which we are representing, and at anode what happens, as I already told you in the beginning, at anode oxidation takes place. So your zinc gets converted into Zn plus 2 ions plus 2 electrons. So this represents your left part. On the right part, you have your cathode. You have to represent your cathode, and at cathode we have reduction process taking place. So at cathode what happens, you have your copper plus 2 ions, and they gain 2 electrons which have been released by the zinc, and copper plus 2 ion gains the 2 electrons from there, and it gets deposited as copper at cathode. Now whenever we talk about your electrode potential, now this new term comes which I will discuss further. So you have this very important formula, E naught cell equals. So I will generalize this first for the case of Daniell cell. So for the Daniell cell, your E naught cell equals E naught Zn to Zn plus 2 plus E naught Cu plus 2 to Cu. So this is your basic generalized formula. Now, what does this E naught cell represent? This represents your standard electrode potential. Standard electrode potential. Correct. Now, coming to electrode potential, we have another term defined, which is electrode potential. Okay. Now, what is electrode potential? So, your electrode potential is defined as the potential difference between the electrodes and the electrolytic solution. So, that is your electrode potential. So, your potential difference, potential difference between electrodes, so your cathode and anode, and electrolytic solution, electrolytic solution. So this is termed as electrode potential. Now we cannot determine electrode potential of any one electrode experimentally. You will have to calculate electrode potential for first for the whole system, and then you will have to define it individually. As I talked about in the previous formula, E naught cell equals E naught Z into Zn plus 2 plus E naught Cu plus 2 to Cu. Now, your electrode potential is of two types. So this is defined as of two types. You have your oxidation potential and you have your reduction potential. Okay. So you have your oxidation potential and we have our reduction potential. So your oxidation potential, E oxy, or you represent it as E M to M plus. Why M to M plus? Because your oxidation is loss of electrons. So as we saw in the case of Daniel cell, your zinc gets converted to zinc plus 2 electrons. So that is why we have written here M to M plus. And your reduction potential, E reduction or E M plus 2 M. So as we saw in the case of Daniel cell, Cu plus 2 in aqueous state plus 2 electrons. So this gets converted deposited as copper at the cathode. So your oxidation potential is represented like this and your reduction potential is represented like this. Now we talk about standard electrode potential. So standard electrode potential. So basically, this is standard. So that means that electrode potential, which is measured at your standard pressure, which is 1 bar, and at fixed temperature, which we generally take as room temperature, and the concentration of all the ions is 1 molar or 1 mole. Okay, so that is your standard electrode potential. Again, this is divided into two subparts. Standard oxidation potential. And one more thing, this your standard electrode potential. This is represented as E naught cell. Okay, and your electrode potential is E cell. So what is the difference between electrode potential and standard electrode potential? Nothing. Standard electrode potential is electrode potential at standard conditions. That is 1 bar pressure, your normal temperature or room temperature, and very, very important, concentration of all the ions is 1 molar. Okay. And you have two types of standard electrode potential, E naught cell, standard oxidation potential, and standard reduction potential. Okay, so your standard oxidation potential, just like it will be represented, except E naught, what will we write here? We will write here M to M plus. And here you will have your E naught reduction or E naught M plus to M. Now, um, we move on to further topics. So your electrochemical cell is made up of anodic compartment and cathodic compartment. You have your oxidation half reaction, you have your reduction half reaction. Okay, now moving on, we have Nernst equation. Nernst equation. So this is a very, very, very important equation because in board exams they will directly ask you, you can say, 2 to 3 questions, or at least one question is there which will directly numerical portion which will be directly solved using this Nernst equation. This is very, very, very important. Now in Nernst equation, so let's say we have a reversible cell reaction. So for a reversible cell reaction, now what is a reversible cell reaction? So it will be something like this, right? Cc plus GD. Okay, so your reversible reaction will be something like this. Now here we define a thermodynamic aspect, delta G. So your delta G from thermodynamics, as we know, it is defined as delta G naught plus RT ln Q. Here your Q is your charge. Okay, so this equation we have from thermodynamics. Okay. Now what happens? See, your Q or your this Q here represents charge. This Q also represents your activity quotient. Okay. Now, your whenever we talk about, see, charge and activity quotient are equivalent in this case because in thermodynamics you have to solve for various cases. So your Q may also represent as charge, or it may also represent as activity quotient. Now, whenever we talk about activity quotient, so this will be something like this. So your activity of C to the power C into activity of D to the power D upon activity of A to the power A on activity of B to the power B. So from this two equations, we get your Nernst equation. So your Nernst equation is something like this: minus NF E cell equals minus NF E naught cell plus RT ln(q). So your derivation is not important for board exams, but your Nernst equation is very important with respect to board exams. So finally, your Nernst equation on resolving the whole equation, you get something like this: E cell equals E naught cell minus RT upon NF ln(q). So this equation is known as Nernst equation, and this is very important with respect to your board exams because your questions are directly asked from this in your board exams. This is a very important reaction. Okay. Now when you try to convert, okay, so your ln is your log base e. Okay, generally when we talk about log, we have log base 10. But here this ln represents your log base e. So for converting this ln to log base 10, you have to multiply this by 2.303. So this is a mathematical expression which you have to remember. So now when we talk in the case of log, not ln, so you have your equation like this: E cell equals E naught cell minus 2.303 RT upon NF log of Q. So in exams, what will happen in your board exams? They will in the questions you will be provided the value of this part, log q. You will be provided the value of this part, and there will be a equation given, such as I told you, a plus bb, something like that equation will be given, and you may have to calculate. So suppose they give you this and they get to tell you to calculate e naught cell or the opposite. So like this, many questions can be asked from this topic. Okay. Now one last basic example for the derivation of Nernst equation. So suppose we talk about Daniel cell. Okay. So in your Daniel cell, you have two half reactions. You have a oxidation half reaction and you have a reduction half reaction. Correct? If you guys have any doubts, please put it in the your chat section. I will address your doubts right away. Okay. Now moving on. Okay, so you have your oxidation half reaction at anode. So the reaction is something like this. Your zinc gets converted to Zn plus 2 aqueous state plus 2 electrons. Correct? And at cathode, you have your reduction half reaction. So reduction half reaction is something like this. Cu plus 2 in aqueous states plus 2 electrons gives you copper in solid state. Correct. Now, if you try to write this reaction as a whole, so your reaction will be something like this. Now, watch this very carefully. Zinc in solid state plus copper plus 2 in aqueous state. This is one side of the reaction, and the other side will be zinc plus 2 aqueous states plus copper in solid state. Now, whenever we talk about this activity quotient, so this will only take the concentrations of the ions only. The solid state has no role in it. Okay, so this will be your Q. So now your if you try to write Nernst equation from this, so the Nernst equation will be E cell equals E naught cell minus RT upon NF ln Zn plus 2 upon Cl plus 2. So this will be your Nernst equation for Daniell cell. Okay, this is your Nernst equation for Daniell cell. And in most of the cases, your in board exams, you will get a 3-mark question or a 4-mark question where they will ask you to first define types of electrolytic cells, type of they may ask you the working of Daniell cell and the role of salt bridge, and they may give you some numerical related to electrode potential or electrochemical potential, which can be solved using this Nernst equation. So this was ideally how you should study your electrochemistry chapter. How should you begin your electrochemistry chapter? That first you have to talk about what is electrochemistry, types of electrochemical cells. Then, as we saw, that by discussing and understanding the working of Daniell cells, we can also understand other concepts through the same example. Okay, so this is a very, very important part which most of the students miss. They usually do not focus this much. Okay, and please subscribe to our YouTube channel, and you can also register on our website for upcoming various revision courses for board exams, and we also have some courses related to CBSE. Okay, so that will be all, and I enjoyed having a session with you all. Thank you.